from a set A to a set B is a mapping that assigns each element in A exactly one element in the set B. The set A is called the domain of the function and the set B is called the codomain of the function. The set of elements which we map using the definition of the function which we assign each element of x in B is called the set of range, or simply the range of the function f. So there is a considerable amount of attention that has to be made in the definition of a function, because in the definition we have said that each element of A must be matched with an element of B, and each element in A must be matched not more than once. Some elements of B may not be attached to any element of A, and there may be the case where one element in element B in set B is attached twice or more than twice. So let's consider some examples of functions. You can see that the map f is relating the point x in the first set to the point y1 in the second set. It is a function because each element in the domain is attached to another element. Let's see some examples of functions. The set A is containing only one element x, and the mapping. Let's consider some examples of functions. You can see that the map f is relating the point x in the first set to the point y1 in the second set. It is a function because each element in the domain is attached to another element. Let's see some examples of functions. The set A is containing only one element x, and the mapping or the function f assigns x another element y1 in codomain B. You can see that this is a function. Why? Because each element in the set A, the domain, is assigned exactly one element in the codomain, which is y1, but y2 is not assigned to any other element. Now in the second example you can see that the domain contains 2 points x1 and x2, and the function f maps both of them to a point y in the codomain. This is still a function because each element in A is assigned a value in B. In the second example you can see that the point x1 is related to the point y in the range through the function f, but x2 is not related to any point in the range. So this is not a function because there are points in the domain which are not related to any point in the codomain. Let's go back to the previous slide. Here we can see that in the first example x is related through f to a point y1. We call y1 as the image of x under f, or we say x is related to y1 through f. Now for a given input x, the output of a function f is called the value of f at x, or the image of x under f. Sometimes we write y is equal to f of x. This is the equation representation of the function. In this representation, the point y is called the dependent variable and the input x is called the independent variable, and we read it as y is equal to f of x. For a function f of x defined as 3x minus 4, f of 5 is equal to 3 times 5 minus 4, and this gives us 11. Similarly, f of minus 2 is equal to 3 times minus 2 minus 4, and this gives us minus 10. So we say f of 5 is 11 and f of minus 2 is minus 10. We call a function f as real valued function of a real variable if both independent and dependent variables are real numbers. For example, in the previous example of function f of x, our independent variable is x and it assumes real values. At the same time, our answers are real values as well. So we say that f is a real valued function of a real variable. What is the graph of a function? The graph of a real valued function f in the xy plane is defined by the graph of equation y is equal to f of x. The points on the graph of the function f of x are therefore in the form x f of x. The ordered pairs x, y define the graph of the function f of x.